Welcome to the Dingir-Zone. Hi, I'm Victor, and you may know from my other channel that I'm a computer scientist, and today I'm going to use my programming knowledge to disprove or to try and disprove evolution. So I'm going to write a little Python program here that will simulate evolution, and the output of that program is then going to show that evolution just doesn't work and the evolutionists are just stupid and everything's nonsense. Okay, so how is that program going to behave? Let's look into the Wikipedia article of evolution. What does it say how evolution works? Up here it says, more offspring are often produced than can possibly survive. Traits vary among individuals with respect to their morphology, physiology, and behavior. Phenotypic variation. Different traits confer different rates of survival and reproduction. Differential fitness. And traits can be passed from generation to generation. Heritability of fitness. In successive generations, members of a population are therefore more likely to be replaced by the offspring of parents with favorable characteristics. So we need to have some system to have multiple generations. Okay, this talks about happening across generations. So let's start with a function main, which will simulate a number of generations that I can then pass as a parameter. When I start this with, let's say, 100 generations. So I'm going to simulate this thing for 100 generations. Okay? And then it talks about a number of offspring that can possibly survive. So in different surroundings, a different number of individuals can survive. So let's make this another parameter. Resources. So this is going to be a number that describes how many individuals can be sustained in the area that we are simulating. So let's say 20 entities of some species will survive. Okay, that's just how much food there is or whatever. So the area is able to sustain 20 animals of some kind. Okay, and then in here we will loop over the generations. Each iteration of that loop is going to be a generation. And in every iteration we have to create the next generation from the current generation. Okay, so we will have to start with some initial current generation, and I will just make an array of zeros, and one entry for each resource, for each individual that we can sustain in this generation. So we'll just start with 0 for everything. Good. Now in every generation I want to have some information about what's going on. I want to print that here to this shell. So I will print this in CSV format so that I can then paste that into Excel or LibreOffice Calc in my case here. Okay, so this will just print the current generation separated with semicolons. If I run this, yeah, you can see it starts with all zeros and it just stays the same in each generation because I'm not doing anything with the data yet. So, traits vary. So this means that we have, so-called mutations. And I will just model that as adding or subtracting a random number from each element for the next generation. So next generation will be again an array with resources length. Okay. And then at the end of the loop I will replace the current generation with the next generation. Okay. Good. And in between I will change the entry of the next generation to one from the current generation. By adding or subtracting random.uniform. I will make that another parameter, how far I'm allowed to change it. And I will then change it to a random value between minus mutation and plus mutation. Okay. And for this I need to import the random package so that I can access this random.uniform. Okay, so between two generations I create the next generation, fill it with values from the current generation with plus or minus a random number between minus mutation and plus mutation. And let's just take the value 5 for that. So in every generation I can add or subtract a value between minus 5 and 5. So let's run this. Okay, this output looks interesting. Let's paste this in LibreOffice Calc. Okay. And now let's let it create a graph so that we can see what is going on. Chart. Yeah, this is what I expected. It's complete nonsense, right? It's everything's just all over the place. It's going up and down and up and down. And but okay. What else? Evolution doesn't stop there. We have natural selection. Okay, which means that with different fitness to the environment, and the fitness is what I've modeled as this numerical value, with different fitnesses to the environment, you have better or worse chances of survival. So we still have to implement this selection phase. Okay. So this is mutation. So before we are done constructing the next generation, we have to select which of the new and old elements survive. Okay. So I will do that by just throwing them together. So I will put both of them together in one array now. Then I will sort it so that the elements, the animals with the better fitness to the environment move to the right of the array. Okay. And now remember only this many of the animals will survive, so we will now simulate that by killing the other animals. With this array slicing technique, minus resources, colon. So with this, we just take the last animals, the rightmost animals, and this number, the rightmost 20 in this case, animals. So this is the selection phase. Okay, let's run this. But let's see what this data now looks like. Insert chart line. Okay, this is not looking so random anymore. So it looks like random mutations filtered by a selection and then repeating that that whole process over generations is not so random apparently. So that improves the overall outcome with respect to some selection function, huh? So, okay, what can we now do to still disprove evolution? I mean, humans get the DNA from their parents, right? So humans do have mutations, right? You don't have just the DNA of one of your parents. This is a change. Humans and other animals, of course, breed across multiple generations, and well, then there's only natural selection left, but natural selection just means your chances of survival, right? If you are better fitting your surroundings, like a giraffe with a longer neck is able to survive in an area where the trees are higher, right? So so having a long neck would be a trait that would be beneficial. So yeah, this would mean that just the principles of math, of probability theory, would have to be wrong for natural selection to not work. Okay, so what we have is that in nature we do have mutations, we do have selection. We have seen that this combination does improve a species. I'm sorry to disappoint you, but it seems I've accidentally proven evolution. Sorry.